The idea of biological control in some respects is very attractive, as opposed to something like DDT, which is very harmful to the environment. If you could have a biological control, for instance, another animal eating the intermediate host or one of the vectors of a parasite, that's a great idea, because that doesn't involve something that generally harms the environment or disrupts the ecology, at least in most cases.
Another avenue of protection is the development of a vaccine against parasitic infections. Dr. Stephen Hoffman and his team at the Navy Medical Research Center in Bethesda, Maryland, are developing groundbreaking vaccines for malaria. The team begins with thousands of Anopheles mosquitoes from the research center's insectary. Volunteers are bitten by malaria-infected mosquitoes that have been exposed to radiation. The radiation weakens the malaria parasites harbored within the infected mosquitoes. The weakened parasites evoke responses from the volunteers' autoimmune system. After thousands of these responses, the volunteers develop immunity to malaria. While progress towards a workable vaccine is made every day, the complex nature of parasites creates a moving target for medical science.
They have multiple antigens or proteins that are expressed on their surface at different courses in their life cycle that makes the design of a vaccine almost impossible.
The more we learn about these parasites, the more respect we gain for their side of the life cycle, and the more respect we gain for the immense amount of selection those parasites have caused our biology to undergo.
The ability of these organisms to infect new hosts and infect virtually every animal that we know. There's just so many different varieties of parasites and so many complex things that you can learn, as well as simple things.
There's nothing easy about studying parasitic organisms. They tend to be very difficult to maintain in the laboratory. It tends to be very difficult to get large numbers of organisms to study. As a result, doing biochemistry on these organisms is difficult. Doing genetics on these organisms are difficult. Parasitologists, scientists who study parasites, tend to be of a very special breed. There's something else that motivates parasitologists to study these organisms that would not ordinarily motivate a person studying another class of organisms.
The wonder of it all and the complexity of what we see in these organisms, going from single-cell organisms to very complex organisms, from parasites that you have to look at under a microscope to tapeworms found in whales that are 100 feet long.
The ultimate goal of studying parasites and to learn about their biologies is to ultimately exercise some control over the way they spread.
My cousin, Rabbi Filazowski, told me about a Hebrew concept, which he calls tikkun olam, and it means to better the world. It kind of refers to the fact that an individual's obligation in life is to try to want to better the world. And I think that's the one unifying feature I've always seen among my colleagues in parasitology, is no matter what particular parasite they're studying, there is some humanitarian motivation in wanting to study these class of organisms.